Good afternoon, my YouTube viewers. It's Crystal here. What I wanted to do is I wanted to do a code review, but the first code review I did, it crashed on me. So I'm doing it a second time. And basically, so since I'm doing it a second time, I'm going to try to do it as quickly as possible. But basically, what I've done is I've entered the Kaggle Playground competition, Series 3, version 20, and we're going to be using TensorFlow, and we're also going to be using a feature selection with sklearn, which is your recursive feature elimination, which is what we're going to be using for our feature selection. So you can read about that if you like, about recursive feature elimination. So it's just another way to select features, and I got this from somebody else who had entered the competition. He scored really high, he scored really well up the leaderboard, and so I thought that since he scored really well up the leaderboard, I'd look at his code. But my code didn't score nearly as well as his code. It was an improvement. It was a 50-point improvement, but it still didn't score nearly as well as his code. So we're using the Jupyter notebook in the Kaggle, and it's stored in my Kaggle account. And I will leave a link to the Jupyter notebook in the description box down below. So the first thing that we're going to do is we're going to give you the problem statement, and the problem statement is predict on CO2 emissions in Rwanda. And after we put our problem statement in there, we're going to import the libraries into the system. So we're going to import NumPy as NP, which creates our NumPy arrays and also does numerical computations. We're going to import Pandas as PD, which creates your data frame and your series, and it processes the data. We're going to import OS, which is your operating system, and it's going to go into the operating system. We're going to import TensorFlow as TF, which is your deep learning functionality. We're going to import sklearn, which is your machine learning functionality. We're going to import SciPy, which performs statistical computations. We're going to import matplotlib.pyplot as PLT, which visualizes your data, and we're going to import Seaborn as SNS, which statistically visualizes the data. So we also want to see what version of TensorFlow that we're going to be using, and the reason why is because it's always important to know what version of TensorFlow you're on, because TensorFlow has a lot of revisions, and whenever it has revisions, it's going to have deprecated code and new code, and you want to know what you're working with. And I receive emails from Google telling me all this neat stuff that TensorFlow does, but I can't keep up with everything, but I do my best. So after we have imported the libraries that we're going to be using in the system or in the program, we're going to retrieve the files to use in the program. And we're going to use the OS library to do that. And we've got 3 CSV files, being train CSV, test CSV, and submission CSV. So we retrieved those 3 files. Now we're going to use Pandas to read the files, read the CSV files, and convert them into data frames. And then so we're going to have 3 data frames, being train, test, and submission. So you can see train here. Train here has got 76 columns of data. The last column of data is your emission. And we want to see what the columns are, and these are all the columns because it's got a lot of columns. And then we want to see if we've got any null values. So we've got null values. We want to see what the type of columns we're working with. So you can see that, and they're all numeric columns except for the very first column, which is the ID column. Then we go to test. With test, we've got 75 columns of data because the emission column isn't present because the emission column is your target. We do your test columns, which are the same as train except for the emissions. We check for any null values. You can see we've got quite a few null values here. Now we're checking submission. So this is what Kaggle wants to see when you submit your work to Kaggle. So now we're going to delete the ID column because it's not needed. And the reason why it's not needed is because each row is indexed by pandas. So we're going to check to see which rows have null values. And so when we check to see which rows have null values, we can see here that we've got 70 columns. We've got 70 columns that have null values, so that's not very good. If it was only just a few null values, I may even have decided to delete the columns. But since we've got 70 columns with null values, it's going to be a little bit difficult to delete all of those columns. So we've got to do something else. We check on test, and you can see on test there are 70 columns of null values as well. So you can see you can't really delete the columns because if you delete the columns, it's going to affect the accuracy or the error. I mean, you can try to delete the columns and see what happens, but I think it will affect the error when you delete those columns. And so now what we're going to do is we're going to create a map based on the longitude and the latitude of Rwanda. So you can see a map of Rwanda with all these little dots on it, and that's like the shape of Rwanda. Now what we're going to do is we're going to analyze the label. So target equals train.pop emission, and then so we're going to use Seaborn to create a histogram of the target. So you can see here's your histogram of the target right here. So now what we're going to do is we're going to replace all null values with the median in the column. We're going to do that in the train data frame and also the test data frame. So if the sum is greater than 0, then we're going to fill a haze with the mean of that column. And so I just decided to do that. You could have done other things. You could have done like sklearn's iterative imputer, but I just decided to do it easily. There's other things that you can do if you want to go to sklearn. You've got simple imputer, iterative imputer, and KNN imputer, but I just settled for the mean. Now what we're going to do is we're going to perform the Kolmogorov-Smirnov test to see if the columns of data are from the same distribution. This is another problem that we have. We've got 72 columns of data that are from the same distribution. So it's not just 1 or 2. If it was just 1 or 2 columns of data, then we could delete those columns. But since these columns, we've got 72 columns not from the same distribution, then we have to keep those columns and work with what we've got. Now what we're going to do is we're going to make box plots of the year and the week. We're going to use Seaborn to do that. So we made box plots of the year. So you've got 2019, 2020, 2021. You can see 2019 is just a little bit more than 2020, 2021. So maybe that means that Rwanda is trying to do something about their CO2 emissions. And now what we're going to do is we're going to check the box plot for the week number, and you can see that you can see the CO2 emissions for each week of the year, which is really interesting, but you can see it. So now what we're going to do is we're going to use Seaborn to create a heat map of the data. So here's your heat map of the data, and you can see that we've got a few columns that are highly correlated. So now what we're going to do is we're going to remove the highly correlated columns. And when we remove the highly correlated columns, we start out with 75 columns or 74 columns, and we end up with 61 columns. So I'm going to say that's 13. I'm going to say that we removed 13 columns that have a high correlation. I mean, if I wanted to do it, I could have done print len to drop, and then len to drop will probably tell me 13. But I think it's because we're going to say 74 because we deleted the ID, and so 74 minus 61 is 13. So we're going to say there's 13 columns that have a high correlation. So we drop those columns. And now what we're going to do is we're going to standardize this data. And so we used sklearn standard scalar. And so we use fit transform on the train data set, and then we used transform on the test data set. So now we've got standardized data. Okay. Now what we're going to do is we're going to define our dependent and independent variables. So y is your dependent variable and it's your target, and x is your independent variable and it's your train, and x test is train. So now we're going to do rank feature elimination to select the best features. And so from sklearn.featureSelection import RFE, from sklearn.linearModel import linear regression. So I decided to use linear regression because I tried to use SVC, that support vector machine, or SVR, and it just took forever, and I think I probably used the wrong one. I probably used, I used SVR, but it still just took ages to do it, and I thought, well, I can't sit here all day long waiting for this, so I used linear regression instead. And so estimator equals linear regression, RFE equals RFE estimator, x RFE equals RFE dot fit transform xy, estimator dot fit x RFE comma y, calls equals list x calls, temp equals PD series RFE dot support, index equals calls, feature RFE equals temp, temp equals true, index dot to list, and then print selected features. And I couldn't give you your error because that was an internally made function, which I didn't want to put in my code because it was somebody else's code. So we put the rank features into the model. So x equals x feature RFE, y equals y, x test equals x test feature RFE. So we're going to use sklearn to split the data set into training and validation sets. And so you can see that now we only have 30 columns of data in our xtrain and our xfl. So you can see we started out with 75 columns of data, and now we've only got 30 columns of data. So now we're going to import TensorFlow modules for deep learning. So these are all the modules from TensorFlow that we're going to import. And now we're going to create our neural network, and we're going to call it CO2. And you can see that it's the first hidden layer is a ReLU activation. The second hidden layer is ReLU activation. And the third layer is your output layer, and it's linear activation. And so model loss equals mean squared error. Optimizer is RMS prop, and metrics is MSE. So we get a summary of the model, and so you can see there's a summary. Now we're going to train the model. We're going to set up for early stopping and MC, and then we're going to set up we're going to fit the model. So history equals model.fit, xtrain, ytrain, epochs equals 100, validation data equals xval, yval, batch equals 32, callbacks equals early stopping MC. And it says val loss, val ACC equals model.evaluator, evaluate xval, yval. So you print the val loss and the val ACC. So we go all the way down to our epochs until we reach early stopping, and we had a val accuracy of 13,577. And now what we've done is we used Matplotlib to create a chart of the loss, the val loss, and the MSC. Well, the val MSC and the MSC. And so you can see that the MSC is a straightforward going down, and the val MSC is a little bit choppy. So now we're going to make predictions on the validation set. And so I decided, because there were some negative values in there, and you can't have any negative values in the CO2 for Rwanda. So I said ypred equals model.predict xval, ypred equals abs ypred. So that's the absolute value of ypred. Ypred equals ypred.flatten ypred. So you've got your ypred. And then we're going to determine the root mean squared error, that's RMSE, of the trained data, and you've got an RMSE of 115, which isn't too bad. I mean, other people who had made entered the competition had scored better than me, but I scored the best I could. And then now what we're going to do is we're going to use Matplotlib to plot the real values against the predicted values, and you can see that we've got some outliers in there. So since we've got some outliers there, that's going to cause problems as well. And I suppose that if I had wanted to, I could have removed the outliers, but I didn't, but there are outliers that we could have removed. And then now what we do is we create a data frame that puts the actual values and predictions on it, so you can compare the actual values against the predictions. And now what we want to do is we want to predict on the test set. We made predictions in the same manner that we did with the xval, and we use sklearn to create a histogram of the predictions. So you can see that we've got the predictions there, and you can see that basically I made all of the values to be absolute values because there were some negative values in there. And then when there are negative values in there, well, you can't have a negative CO2 emission. So I made everything absolute values. And then what we did was we took our predictions and we put them into the submission data set, and we prepared the data set to be forwarded on to Kaggle for scoring. So this is what it looks like. I could have done better. Maybe, I could have removed the outliers. And that may very well have improved the score. You never know. So, you can do a lot of things to improve the score. But this was just one thing that I did that I was working on since yesterday. And whenever I submitted this particular Jupyter notebook to Kaggle, I had a score of 151, which was an improvement of my previous score, which was 199. So RFE is the way to go. RFE is, it does actually improve your score. And so I'm going to go ahead and conclude this code review. And thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And if you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And I'm not sure I'm going to be making as many videos in the future. I'll still be doing code reviews, but there's a reason for that, but I can't say what it is. But thank you again for watching my code review. I look forward to making more code reviews for you in the future. And I may very well try to remove the outliers and see if that will improve the noise. Who knows? It just might. Thanks again, and goodbye.